Okay, let's try another one. What would be the factors in this one? P of x equals 4t cubed minus 10t squared plus 4t plus 5. What would be the factors of the constant? Plus or minus, whoops, I've left a little bit out. Yeah, the factors of the constant, factors of 5, and of course plus or minus 1 and 5. What would be the factors of 4? Plus or minus 1, 2, and 4. So what would the PRZs be? Plus or minus? Okay, form all the fractions you can with either 1 or 5 as the numerator and 1, 2, or 4 as the denominator. So many different combinations, but it's finite. There's not that many. What are they? So just start with the 1 in the numerator and then create 3 fractions with 1, 2, or 4 as the denominator. So plus or minus 1 over 1, which is 1, and then what are the other two? 1/2 and 1/4. You've exhausted the 1, this one right here, in your numerator, so start with the 5. So either 5 over 1, which is 5, or 5/2, or 5/4. This is your list of suspects, right? This is your lineup. So we graph. Okay, so we have 4x cubed minus 10x squared plus 4x plus 5. In the calculator, I had to use x instead of t. Zoom number 6. What do we see? Oh, I only see 1. And, okay, which one does it look like it might be out of our suspects? Positive or negative? Let's see. I'm going to use the calculator to see if that's right. Negative 0.5. 0. Okay, that's going to be right. But that's only one of them. How many do we expect to have? 3, because the degree of P of t is 3. Okay, so let's put the negative 1/2 up in the corner again. What goes across the top? Yeah. All right. And what goes here? Here. 2 or negative 2, yeah. Then here, negative 12. Here. 6 here. Here. As expected, we get 0 remainder. Now, what's the good news about the remaining coefficients? They're coefficients of what degree quotient? We started out degree 3. We divided by a linear polynomial, x minus, or actually it was x plus 1/2 we divided by, which corresponds to a 0 of negative 1/2. And so the remaining quotient has degree 2. So this would be 4t to the second minus 12t plus 10. And that quotient is going to contain the remaining zeros. So what do we do to find them? Well, first we set it equal to 0. Now, before you use the quadratic formula, what would make your life just a wee bit easier? You could factor out of 2, or since it's an equation, you could divide out of 2, because 0 divided by 2 on the right side is still just 0. So what do we get on the left side when we divide everything by 2?
2t squared minus 6t plus 5.
There you go. Okay, fill in the good old quadratic formula. Whoops, I said x out of habit. Should have been t equals what? Negative b plus minus square root b squared minus 4ac all over 2a. So fill that in. What do you get? Bless you. Minus 425. I like the way you said 4 times 2 times 5. That's the b squared minus 4ac right there. All over. There you go. So 4. All right, so that's supposed to be a 4 right there. It doesn't look like it. So if we do that multiplication, what do we end up subtracting from 36?
40.
So that's going to be what underneath the radical?
Negative 4.
-4. Okay. So we get 6 plus or minus the square root of -4 over 4. What's the square root of -4?
2i.
Okay. You guys remember how to simplify? So we get 6 plus or minus 2i over 4. You remember how to simplify that?
Go out of 2.
Okay, so out of where? The
top.
numerator. Okay. And then what's left in the numerator?
3 plus or minus I all over 2. Because the 2's cancel.
Because 2 over 4 is 1 over 2, right? So you could write this as 3 plus or minus I over 2 if you want. Does that make sense? Okay, I think we got them all. We've got all 3 because there were 3. So we've got zeros of what? -1/2. And then 3 plus or minus I over 2. So these are your zeros. By the way, you can use your calculator to check these, even the complex ones. You just can't do anything with the graphing of the complex number.